Hello, welcome friends. Me Anila. The topic of my discussion is about combustion. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve toughest numericals on combustion. What is combustion? When organic compound containing carbon, hydrogen, oxygen is burnt in the presence of oxygen, it produces carbon dioxide in water, and this carbon dioxide and water, if their amount are known and the amount of sample is known, we can detect the compound by empirical formula and molecular formula. Empirical formula is the simplest ratio between atoms and molecular formula is the actual molecular formula of a compound. So in this video, I will tell you how to solve numericals on combustion. Example, a compound containing carbon, hydrogen and oxygen is combusted. 0.45 gram sample gives 0.1836 gram water and 0.6732 gram carbon dioxide. Molar mass is 176 gram per mole. Find empirical and molecular formula. So we have an organic compound containing carbon, hydrogen, oxygen. After combustion, the amount of water is 0.1836 gram that is produced. Amount of carbon dioxide is 0.6732 carbon dioxide produced. Amount of sample is given, molar mass of sample is given. We have to detect the compound and its empirical and molecular formula. Solution. First, we have to calculate the empirical and molecular formula and detect the compound. First, we will calculate the amount of carbon, hydrogen and oxygen in a organic compound. For this, we will take first moles of carbon dioxide. Moles of carbon dioxide is equal to amount of carbon dioxide divided by molecular weight of carbon dioxide, that is 0.6732 gram divided by 44 gram per mole is equal to 0.0153 moles. 44 gram per mole is the molecular weight of carbon dioxide. So the moles of carbon dioxide are calculated to be 0.0153 moles. Since 1 mole carbon dioxide contains 1 mole carbon, so 0.0153 moles carbon dioxide contains 0.0153 moles carbon. So we have calculated the moles of carbon. Now, moles of water is equal to 0.1836 gram already given divided by molecular weight of water 18 gram per mole. The moles of H2O is calculated to be 0.0102 moles. Since 1 mole H2O contains 2 moles hydrogen, so 0.0102 moles water contains 0.0204 moles hydrogen. So we have calculated moles of carbon and moles of hydrogen. Now we have to calculate moles of oxygen. For this, first, we will calculate amount of carbon from moles. 0.0153 moles multiplied by 12 is the atomic weight of carbon. Answer is calculated to be 0.1836 gram. This is amount of carbon in the organic compound. Amount of hydrogen is moles of hydrogen 0.0204 moles into 1 gram per mole is the atomic weight of hydrogen. The amount of hydrogen is calculated to be 0.0204 gram. We have calculated moles of carbon, moles of hydrogen, amount of carbon, amount of hydrogen. Now we will calculate amount of oxygen. Since the total amount of sample is 0.45 gram, so we will subtract amount of carbon and amount of hydrogen from amount of sample, that is 0.45 gram minus 0.1836 gram minus 0.0204 gram. Amount of oxygen is calculated to be 0.246 gram. Now we will calculate moles of oxygen. Moles of oxygen is 0.246 gram divided by atomic weight of oxygen, that is 16 gram per mole. Moles of oxygen is calculated to be 0.0153 moles. Now we have calculated moles of oxygen, carbon and hydrogen in organic compound. Now we will use mole ratios. Carbon is to hydrogen is to oxygen. We will write their moles. 0.0153 moles carbon, 0.0204 moles hydrogen, 0.0153 moles oxygen. So these are moles of carbon, hydrogen, oxygen. Now we will divide these moles by the smallest number. In three of them, the smallest number is 0.0153 moles carbon and oxygen. So we will divide all these moles by 0.0153 moles. We get 1 is to 1.333 is to 1. Now we will multiply these ratios with 2, but we will not multiply by 2, because if we multiply by 2, then 1.333 becomes 2.666, which is not a whole number. So we will multiply by 3 instead. Multiply by 3, we get 3 is to 3.999 is to 3. Because 3.999 is approximately equal to 4, so the mole ratio appears 3 is to 4 is to 3. So empirical or simplest formula is C3H4O3. So we have calculated empirical formula. Now we will calculate empirical formula weight. 3 is the number of carbon atom into 12 is the atomic weight of carbon, plus 4 is the number of hydrogen atom into 1 is the atomic weight of hydrogen, plus 3 is the number of oxygen atom into 16 is the atomic weight of oxygen. Empirical formula weight is calculated to be 88 gram per mole. We will calculate value of N, that is molecular weight divided by empirical formula weight. So N is equal to molecular weight is already given in the example, 176 gram per mole divided by empirical formula weight, that is 88 gram per mole. After solving, the value of N is calculated to be 2. Now we will calculate molecular formula of unknown compound. So you have to memorize this relationship. Molecular formula is equal to N into empirical formula. The value of N is 2 into empirical formula is C3H4O3. We will multiply empirical formula with 2. We get C6H8O6. So C6H8O6 is the molecular formula of unknown compound. So the compound is ascorbic acid containing 6 carbon, 8 hydrogen and 6 oxygen. So in this way we have detected the compound. It is ascorbic acid, its molecular formula and empirical formula calculated. Compound is ascorbic acid. In this way we can calculate formulas in combustion. In combustion, organic compound is burnt in the presence of oxygen and carbon dioxide, and water is formed. And if we have the amount of carbon dioxide and water and the amount of sample is given, we can detect the compound. In this way, we can calculate formulas in combustion. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.